complete that, and then I will, if there is any question, you can ask, or we can keep all the questions at the end of the presentation, and then we will run through the other presentation also. And my suggestion is, we can, if you have any question, you can ask together. And in the meantime, if you have any question, you can even put it in the chat box. I will answer it today, and then I will say it can be circulated tomorrow. What is acceptable to you, I will honor it. Okay? Is it all right?
All right, sir.
Okay. Participants are not talking
Sir,
at all.
sir, they are at far away, sir. Mike was with me only, sir. In,
Okay. 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 Anyhow, so the procedure is like this. Some 3 or 4 slides are remaining in the first presentation. I will complete that. And any questions, you can put it in the chat box. The second presentation, I will run through. And finally, we can ask any questions related to these two presentations, we can ask at the end of the presentation. Okay. So the second presentation may also take around 90 minutes because we have lost some time actually. So we will continue up to 5:40 or 5:35 to 5:40. Is it okay with you, sir? If you permit us, then I will do. Otherwise, I will.
sir, I will ask the participants, sir. They are from different part of here. HESCOM. I will ask them, sir. 5:30.
Hmm.
5 बजे सर मुश्किल से 5 बजे 5:30 सर 5:30 सर
Okay. No problem.
ओके सर
No problem. Okay, then. So the previous first presentation, AMI in India. Okay. What are the main drivers? Number one, demand shortage, theft management, load control, system automation, better system economics. System economics means how reliably, economically, optimally you can manage. Okay. So the government has taken a step forward in long-term AMI direction by defining a sort of similar system in RAPDRP. That is what we are discussing today. That is RDSS program. Okay. Combination of radio frequency. Okay. This is very important. DLC, GPRS communication. Okay. It seems to be a favorable thing in the Indian condition. More work needs to be done with reference to detailing the system functionality, overall implementation, and technology trials. The functionality of AMI. Number one, remote and local reading. Customer supply control, like customer disconnection, customer reconnection, auto disconnection. Auto disconnection means it is programmed automatically. It will disconnect if there is an abnormality. Time clock synchronization, that means make your clock in line with the real time clock. Okay, real time management. Load control. Load control group, control load management at meters. Okay. So when we are talking of this functionality, most of the major functionalities are related to the billing. Okay. Connection disconnection. Okay. Temper detection. Okay. Remote firmware. Okay. Power quality management. Okay. Demand side management. These are all the main functionality of the AMI system. Okay. So the AMI system shall help utility to manage their resources and business process very efficiently. For example, it will have remote meter data, time of the day data, prepaid functionality, net metering and net billing, alarm event and detection, remote load and limiter, remote firmware upgradation, integration with other existing system like IVRS, intervoice. Okay, this is where the billing mechanism will also come into picture. Okay, import of legacy data, security data feature, etc. All these things will come into picture. What are the main challenges on integrated AMI standardization? One is integration. AMI is a totally complex system of technology that must be integrated with utility into information technology system, including CIS, GIS, OMS, WMS, and workforce mobile management. Standardization is another important aspect. Interoperability standards, it need to be defined with set uniform requirements. AMI technology deployment and general operations are the key to successfully connect, maintain AMI based grid system. This is the subset of AMI. For example, smart meter, maybe a single phase meter, three phase meter. Okay. Communication, maybe PLCC, maybe Zigbee. We will talk more about these things. GSM. Okay. Data concentrator, DCU, and meter data management. This is how the subsets of AMI are being worked out. So this is the conclusion. In recent years, with advancement in communication technology, information technology, and also increased requirements of various sectors of the power industry for monitoring, controlling all the network components from production to consumption. Okay, we feel necessary to add intelligence in the digital platform, that is the AMI. And AMI certainly will help several things in the philosophy of metering today: smart meter reading, smart meter billing, communication technology, cost implementation angle. Several things will come into picture. So this is how the conclusion is: AMI faces many challenges but has the potential to greatly increase the energy efficiency of the nation. Advanced metering infrastructure are systems that measure, collect, analyze energy usage, and communicate with metering devices such as meter, gas meter, heat meter, whatever it is, and either on request or on schedule. So these systems include hardware, software, communication, consumer energy display, and controllers. So this is how the whole thing has happened. So thank you for the first presentation. Any questions you have, you can put it in the chat box, and we will go for the second presentation, and then we will finish those presentation, also that presentation also. And then in case any questions you have, oral question, you can definitely ask at the end. I am available in LinkedIn. I'm available in this mail. And if you have any question, you can always even contact me also directly. No issues. Okay? Right? Okay. Senthil,
Yes, sir, I'm there, sir.
if they have any questions, please collect that, put it
Okay,
in
sir.
box,
Ah,
and then let me address it either at
sure.
the end of the day or tomorrow. No problem.
Okay, sir.
Okay. The second presentation is actually advanced metering infrastructure and smart meters integration. Smart meter data exchange protocol, AMI communication network component, and technology selection. Which technology, like 2G, 3G, 4G, radio frequency, PLC, etc. So this is what we are going to discuss actually. So the overview of the presentation. In this presentation, we are covering communication technology. This is a very lengthy presentation, and case studies of advanced metering, national and international, both we will discuss, because that will give you a correct picture of how to proceed. Third is integrated arrangement of advanced metering, how you can integrate them together, and what are all the main process of integration. So we will see all those things. Communication technology in AMI system. Okay. So here you have a smart grid. Smart grid comprises of the communication, the information technology, the power, existing power grid. Like a technology that deploys various technological advancement to bring in efficiency, reliability, and affordability. So, like monitoring, analysis, control, integration. What is this? A system where megawatts of power controlled by megabytes of data. This is how we have to proceed further. I think this particular thing has been shown how we can proceed. And now we will have this smart grid as an analogy to the human body. The smart grid intersects the electrical grid with automation, communication, and IT systems that can monitor power flow from point of generation to point of consumption. Okay. So this is the layer infrastructure. Like this is the physical network, communication network, information technology. These two things will make a grid a smart grid. This is the existing grid. Existing grid plus communication plus information is the smart grid. This is analogous to information technology, is analogous to brain, which will carry megabytes. Communication, nervous system of the body, it carries megahertz. Physical network carries the muscle, analogy is muscle, it carries megawatts. This is how the analogy. This is taken from Wikipedia. Smart grid, smart meter, or smart grid, or AMI, basic communication architecture. These are all the smart meters. LAN, maybe PLC. Collector, tower repeater. WAN, telephony broadband. Application like MDMA, meter data management system, or meter data management agent, billing, outage, and distribution automation. Okay, or we call the distribution automation is one of the most important aspects in the automation engineering. Okay, so the second here, the second model is this actually smart meter. This is the communication. This is the operational management. Here you have the radio frequency. This is the data concentrator. This is RF, radio frequency. Fan we call field area network. Okay, this may be 3G, maybe any other mode of communication. This is a WAN. Okay, this is the head end system, and this is the meter data management system, network management system. This is WAN and fan. We have WAN and fan. WAN is wide area, and fan is field area network. Field area network consists of either a home or a shop or a factory. And this is the data concentrator. As you can see here, this is the data concentrator, and this is the utility company consumer. Here you have the BPL network, broadband over power line network. This is the fiber wireless network. This is the concentrator. This is the distribution substation. This is how we know the WAN and fan system. This is the communication topology. I think this I had shown it in the earlier slide. It is not required here. But anyhow, just you will have LAN, WAN, NAN, and HAN. Here you can have either Zigbee or PLC, and it is totally integrated with the PV system, wind turbine, anything distributed generation. Okay. Communication technology for smart meter. The technology may be PLC, power line, maybe GPRS, maybe 3G. We will discuss what is 3G, 2G, etc. Don't worry. Wi-Fi, radio frequency, LAN, etc. The advantage is secure, reliable, low OPEX, etc. Certain disadvantages are there. For PLC, length of line. For GPRS, high cost. For Wi-Fi, coverage. For radio frequency, susceptible to strong noise. For LAN, optical fiber, dedicated cabling. Okay, this is the smart grid which needs secure communication, and a model conceived by NIST, National Institute of Standardization and Testing. Okay, so this is the institute which is located in USA, focusing on the development, engineering, design, and upgradation of standardization in the field of smart grids and smart meters. Okay, this is generation, transmission, distribution, customer. And you have here the market, operator, and service. 7 clouds are there, 7 domains are there. So yeah, this is the electrical connection, dotted line, and the main line is the secure communication flow. Everything, every operator, every service provider, every customer, all the market, they are connected through that entire networking. This is how the smart grid operates. This is home area network. The yellow one is the energy monitor. Okay, and the electrical connection is the blue line, and these are all the smart meter gateway. This is the HAN, home area network. Okay, this is wide area network. Here the blue color one, what we can see here is the master and customer meter, MECM. Okay, fine. And then the green one, parrot green one, is the data concentrator unit, DCU. Fine. And then the other one is the network operation center, that is the NOC. This is wide area network. How it looks, What it does is given very clearly here. Okay. I think this is a slide which covers, the communication components, cellular technology, what are all the benefits, wireless technology, and then hardline technology, and then BPL and PLC technology. These are all the main technology applications which are used on the module for the benefit of the customer, and which challenge it will pose, what challenge it will pose is very important. For example, cellular, high variable expenditure. Wireless, infrastructure cost is very high. Hardline, fixed cost is high. BPL, frequency interference and noise ratio. So most deployments rely on multiple technology to achieve full coverage cost effective solution. What is Lora? Lora, is being heard today. Lora is nothing but a wireless technology developed for low power wide area network. LoRa, LO is low, RA, RA is range. Okay, low power wide area network, LPWAN, low power wide area network. Very important thing actually. It's essential for Internet of Things and machine to machine application. So the technology offers very high penetration, low bandwidth, and low energy wide area. You can see here, this is the penetration, this is the smiley, and this is the rat face actually. What is local area? Battery. Low power, here, very important is 45%. And then smiley is low power consumption. Okay. Here, existing coverage, high data rate, cellular. Okay. Traditional machine to machine communication. Machine to machine is one thing, which will understand the communication technology. Salient features of LoRa: long range, maximum life, multi usage, low cost. So this is how the LoRa technology is coming into picture. This is another technology. Communication technology for smart grid and AMI. Wireless communication. IEEE 802.15.4 Z wave. This is wireless communication. Z wave. IEEE 802.11. IEEE 802.16. Okay. LTE and LTEA. This is long-term evolution. This is your 4G configuration. I will talk to you more about it. And this is as per IEEE 802.22. You have to remember these things. And in case you don't remember, don't worry. All these things are available in internet. You just Google or you go to LinkedIn and then find out, these particular things. It is available. Anyhow, for your information, I have collected and segregated them together to make sure that it will give you a comprehensive idea of the technology in AMI technology. Okay. Communication technology for smart grid, particularly wired communication, power line communication. This is IEEE 1901, broadband over power line, BPL, and ITU TGHN we call. ITU is nothing but, International Telecommunication Union. What is GHN? GHN is the name for the upcoming wireline home networking standard developed under the umbrella of International Telecommunication Union. ANSI is American specification. So the wireline communication technology may be fiber optic, maybe Ethernet. Okay. Zigbee. What is Zigbee? Zigbee is a short range, low data rate, energy efficient wireless protocol. Okay. Zigbee uses 16 channels in 2.4 gigahertz ISM bandwidth. What is ISM? Industrial, scientific, medicine. Doesn't need licensing actually. 13 channels in 915 megahertz, one channel in 868 megahertz. Okay. It supports data rate of 250 kbps, 100 kbps, 40 kbps, and 20 kbps. So Zigbee smart energy profile aims to support the need of smart metering and AMI and provide communication among utilities and household devices. So LoRa, short for long range is LoRa, is a spread spectrum modulation technique derived from chirp spread spectrum technology, CSS. This is LoRa is given like this actually. Governing body, Lora Alliance. Standard 801.15.4G. Frequency, okay. ISM 868 stroke 915 megahertz, okay. Range up to 5 kilometers and 15 kilometers rural. Data rate 27 kbps. Modulation, chirp spread spectrum based on FM modulation technology, frequency modulation technology, okay. And also security, 32-bit CRC, cyclic redundancy check. This is a computational check to have the gateway in the system engineered module, okay. This is LoRa, which I have already discussed in detail. Next, we will go to what is Z-Wave. Z-Wave is a proprietary short range, low data rate, wireless RF mesh networking standard. Z-Wave uses 908 MHz ISM Industrial Scientific Medicine band in America, and its data rate is 40 kbps. Z-Wave provides connectivity for devices such as lamps, switches, thermostats, garage doors. Okay. 802.11 Wi-Fi. What is Wi-Fi? Wi-Fi is a technology for wireless local area network, which devices based on IEEE 802.11. Wi-Fi is a trademark of Wi-Fi Alliance. Its data rate is 802.11. Standard range from 1 Mbps to 100 Mbps. It operates in the 2.4 gigahertz ISM band. So the industrial scientific medicine, that is very important because it doesn't need any licensing. Okay. Wi-Fi is targeting home area, neighbor area, and field area. Wi-Fi is already being used for municipal scale networking infrastructure and outdoors. WiMAX. WiMAX uses the licensed bands of 10 to 66 gigahertz. IEEE 802.16 standards also allows the use of license exempt sub 11 gigahertz bands. WiMAX can provide theoretical data rate up to 70 Mbps. You must understand here the technology is growing fast to synchronize with our thinking mechanism in a networking system where the communication is providing a greater assessment and also accessibility for higher distances, long range shots. So Y maximum can provide long range communication for the smart grid. Okay. And LTE, what is LTE? LTE is nothing but your the long term evolution, and LTE-A is advanced version. This is your 4G. The peak data rate for LTE is around 300 Mbps at the downlink, 80 Mbps at the uplink with 200 megahertz channel bandwidth and 4 into 4 MIMO antenna. MIMO is multiple input, multiple output. Typical LTE cell has a diameter of 4 km. By relaying technique, the range can be further extended. What is cognitive radio? This is another communication technology used. 802.22 IEEE. Cognitive radio provides access to unlicensed users. Okay. The bands that are planned to be used by 802.22 are the UHF ultra high frequency, VHF very high frequency bands between 54 and 862 megahertz and their guard bands. We have shown here the spectrum analysis, like spectrum decision, radio sources, spectrum sensing. Okay. Power line communication. Power line communication, they use low voltage power line. It has been already used by some utilities for load control, remote metering. PLC does not have external cabling cost. It is considered to be convenient for home area, neighbor area, and field area in the smart grid network philosophy. IEEE 1901 broadband over power line, BPL. BPL has high data rate exceeding 100 Mbps using frequencies below 100 megahertz. P1901 work group has selected two physical layers for the stand: wavelet OFDM based physical and FFT OFDM based physical. What is wavelet OFDM? Orthogonal frequency division multiplexing. Okay. And FFT OFDM is nothing but fast Fourier transform orthogonal frequency division multiplexing. So these physical techniques aim to improve the communication over the noisy power line. What is ITU? International Telecommunication Union. What is GHN? GHN stands for communication in residential premises, offices, hotels, commercials, etc. GHN is able to operate over all types of home wiring. GHN can support rates up to 1 Gbps. GHN stands for Next Generation Home Network Technology. ANSI is American standard. Fiber optic communication. Fiber optics is already used in the power grid. Today you have FTTH, fiber to home, and Geo is pioneers in this actually today. Fiber optics is not impacted by electromagnetic interference. Optic Ethernet can also be utilized in the smart grid mechanism. It is also possible to employ combination of the wireless, wired communication technology in the smart grid arena. This is a table which I have prepared from LinkedIn. Comparison of communication standards. These are all the standards. IEEE 802.15.4 Zigbee, okay, 0.11, 16, 22, 1901, GHN, CEA. You can see here maximum rate, data, spectrum, range, maximum modes, scope, where it is used. You can select what you want. If you are using in home area network, you can select this. Okay, I will give you a table also. Don't worry about those things actually. What are the main challenges of smart grid communication, AMI communication? Number one, wireless channels they are prone for interference, have lower bandwidth. They do not penetrate well through concrete construction. Their range is limited. The impact of harsh smart grid environment on wireless communication is not explored well. What is power line communication? They suffer from what? Noise, signal to noise ratio, channel characteristics, electromagnetic interference due to unshielded power line. Power line is not shielded today, as you know, and poor isolation among units. These are all the main challenges in the smart grid AMI communication. Now let us understand what is 3G and 4G. Okay, for maximum compatibility for most carriers, 2G, 3G, 4G equipment, that is minimum dual band 800 megahertz cellular or 1900 megahertz PCs, personal computer system, is generally recommended. In many markets, 4G data, that is LTE WiMAX, that is long-term evolution, is on 700 megahertz, 1700 to 2100 megahertz, 1900 megahertz, and 2500 to 2700 megahertz. You don't worry about these figures because all these things are available in the booklet. And also, if you wish, this can be definitely given to you so that you can go through and you can always clarify. If you wish to have clarification, you can always do that. Okay. So 4G LTE wireless broadband is 10 times faster than 3G, and it is able to handle download speeds between 5 and 12 Mbps and upload speeds between 2 and 5 Mbps. So with peak download speeds approaching 50 Mbps, cable speeds vary, but 4 to 12 Mbps are very common. Let us see what is with 5G. In a report, the ITU outlined 13 specifications that networks will need to meet to call themselves 5G, fifth generation. What is this? It is 20 Gbps peak download rate, 10 Gbps peak upload rate, 30 bps per cycle peak spectral efficiency downlink, 150 bps per hertz peak spectral efficiency uplink, 100 mbps user experience download rate, 50 mbps user experienced upload rate. This is what the 5G is. So you can see what is 5G. 5G is the fifth generation mobile network. It is a new global wireless standard after 1G, 2G, 3G, and 4G. 5G enables new kind of networking system, faster, reliable, and it has not come to India yet. It has to take some more time actually. In fact, this year budget, Madam has announced already allocated fund for 5G incorporation in India. In China, America, and some parts of Europe, 5G has become common today. Okay. When we are talking of 5G and when we have not introduced 5G in India, people are talking 6G at Bell Telephone Laboratory and also Nokia Laboratory. 6G is the latest thing. 6G will have ubiquitous computational system, knowledge system, human machine interference, precision sensing. In the era of 6G, which has not come even in the model actually, the digital, physical, and human world will seamlessly fuse together extensively and experiencing the whole thing. It is an intelligent knowledge system will be combined with robust computational capability to make humans endlessly more efficient and redefine how we live, how we work, how we take care of the planet. Even though there is still a lot of innovation in 5G, with 5G advanced release now standards, Nokia Bell Laboratory has already begun the research work on 6G to make it commercially available by 2030. That means to say, definitely in another 10-15 years, this 6G will be dominant in the field of communication technology. This is the future. This is how we know 6G technology is there. Security, spectrum, air interference, network, sensor, extreme connectivity, cognitive, automated, specified architecture. These are all the six key technology for 6G. These are all the six key technologies for 6G. Okay. So now let us understand what is 1G. 1G is first generation, 1980. Second generation, 2G, 1990. Okay. 2G introduced digital voice, CDMA, code division multiplex access. 3G, early 2000, 3G brought mobile data, CDMA 2000. I think probably we are still using 3G here, and our mobiles are also either 4G or 3G, mostly 3G. Okay. Fourth generation, 4G LTE, 2010. 4G LTE ushered in the era of mobile broadband. 1G, 2G, 3G, and 4G all led to 5G, which is designed to provide more connectivity than was ever available before. Okay. Our dream is to make India digital. And when we make digital, 5G is a must actually. So in another 2 years, 5G will come. And you must align your smart meter, AMI, to 5G technology. Okay. With high speed, superior reliability, and negligible latency, 5G will expand the more ecosystem into new realms. Okay, this is what it is. So the 5G technology is expected to provide a new, much wider than the previous one. Okay, high peak bit rate, larger data, high capacity, lower battery consumption, power consumption, better connectivity, larger number of supporting devices, lower cost of infrastructural management, higher reliability, communication technology, as researchers say, with a wide range of bandwidth radio channel, it is able to support the speed up to 10 Gbps. The 5G Wi-Fi technology will offer continuous, consistent coverage, wider area in the true sense. That is what we have to talk about. In fact, this is the 5G in home actually. You can see smart G, smart TV, 5G. Okay. And then here many components, chargers, etc., which are your mobile chargers, your gadgets, anything, whatever you think of in the home networking will be based on the 5G technology. Smart home appliances, products are catching up in the market today. Smart home concept will utilize 5G technology. In smart city, for example, smart city application like, the traffic management, instant weather updating, local area broadcasting, energy management system, power grid, smart grid, and lighting, water resources management, etc. 5G is common. For example, energy management, water management, climate change, smart lighting, predictive lift maintenance, traffic monitoring, 5G has come up in most of the European, American, Chinese part of world actually. But still in India, we have to get it. No problem. Next, we will go what is narrowband versus GSM. So narrowband Internet of Things, NB-IoT, is a standard-based low power wide area LPWA technology. It has a new physical layer and supported by all major mobile equipment, chipset, and module manufacturer. So NB-IoT can coexist with 2G, with 3G, with 4G mobile network. It also benefits from all security and privacy feature of mobile network, such as support for user identity, user confidentiality, entity authentication, data integrity, and mobile equipment identification. Okay. What is Zigbee? Zigbee is an ad hoc networking technology. 2.45 gigahertz, 868 megahertz, 915 megahertz. It is low cost and high data rate. And also it is having an ability to add or remove devices and can support 32 to 255 nodes. Let us understand what is Zigbee. The domestic honeybee, a colonial insect, lives in a hive that contains a queen, a few male drone, and thousands of worker bees. So the survival, success, and future of the colony is totally dependent on continuous communication of vital information between every member of the colony. The technique that honeybee uses to communicate newfound food sources to other members of the colony is referred to as Zigbee principle. This is what Zigbee is. So this is the why Zigbee first of all. Zigbee is a standard fragmented market, many proprietary solutions, low power consumption, low cost, high density, simple protocol. That is how it is used. This is a Zigbee based hand system architecture. Head end service, okay. HTTPS, this is the web cloud actually. Third party, personal energy network. AMI, that is very important actually. We are discussing this. And then here, you have the end user portal, home area network. You have the vehicle charger. This is a battery driven vehicle. Okay. The smart energy meter is here and it is connected on the Zigbee platform. And then here, you can see the storage, etc. And when interconnected with what we call the home energy management system. Market application landscape, long range, short range. This is range actually. This is data rate, low, high. This is the networking, personal area network, local area network, wide area network. This is how from texting to the multi-channel video, the spectrum is there actually. And you can select what you want. Zigbee falls here, and then here, Wi-Fi falls here, and then any other thing, whatever you name, will come here in this. Bluetooth will come here, and then we will see how it is communicated. So this is communication for AMI. As you can see here, real-time monitoring, okay, early realization of dues, recoveries, remote connection, disconnection. Cry out alarm is there here, theft prevention, loss reduction, okay. Remote management, remote configuration, remote firmware upgradation. This is how the communication for AMI is being driven through this smart meter mechanism. Okay. Communication requirement as per application. For example, grid, bandwidth, latency, reliability, security. Distribution automation. For example, low medium. Okay, this is 9.6 to 100 kbps. Latency, strict. Reliability, high. Security, high. Okay, so like that we have substation monitoring. AMI here, this is important. In AMI, low medium, low to medium, that is 9.6 to 100 kbps. Okay, medium 1 to 10 second, there is latency. Okay, low medium, this is reliability. This is high, very high. This is where we have to ultimately go, but ultimately it is the demand response, as I told you in the graph. Okay, so this is how the communication requirement. Okay. So let us see international case study on the communication system on the AMI. This is actually in Houston, USA. RF mesh smart meters are connected here in the mesh pattern. DCU, data concentrated unit gateway. BPL, broadband over power line. Substation, optical fiber, and then here utility data center. This is the connection of a typical communication of an international agency in Houston, USA, of the what we call the communication system engineer. Okay. And this is Italy, NL Italy. They have incorporated around 25 million meters so far. I think one of uh, the biggest records, I should say. 25 million meters are in operation in Italy. Okay. It's part of Europe. And then here, DCU, smart meter, narrowband PLC, as you can see here, GPRS, okay, by way communication, and this is utility data center where this particular thing is connected. Okay, and the typical AMI architecture with RF mesh as last mile. This has emerged as a popular solution among utilities in many geographies. Another case study. Here, you have the IHD in-home display. I told you what is that. Zigbee PLC bidirectional. This is connected in mesh networking because you can see here the mesh. It is meshed actually. Okay, and then DCU gateway communication and GPRS optical fiber utility data center where you get the data driven through. Okay, and here, emerging architecture for smart grid and smart city application, RF mesh canopy. Canopy network is the latest trend actually. It is connected in the form of canopy. That means it totally covered system. Okay. N is the node for any application, like AMI, distribution automation, there's street lighting, traffic signal, control surveillance, etc. This is DCU gateway, optical fiber, utility data center. Okay, communication architecture of our next generation smart metering. This is known as IP metering. What is IP metering? Internet protocol metering. This is SA. SA is smart appliances like your smart TV, your smart geyser, smart heater, smart dishwasher, okay, smart bread toaster. So that will have an internet actually on the cloud, and smartphone. And this is utility data center, HES, and then MDMS. This is the head end system or MDAS we call. This is the application. Okay, and here the top 10 IoT communication protocol to 2021 updated actually. Your cellular technology. This is MQTT. MQTT is a message queue telemetry transport. Okay, Zigbee, Bluetooth, Wi-Fi. This is OPC. That is OPC is nothing but your open platform communication. And then NFC, this is nothing but your the connection actually, near field technology. Sigfox is a French global network operator. LoRaWAN, this is how you have to understand the technology. What is happening in 2021? It is here actually, and definitely it will give you a comprehensive picture of what you need to select, what to do, what you intend to do in the technology domain application. This is a requirement of a smart meter communication network. Number one, transmit and collect data. Number two, ensure the data security. Number three, maintains and manage the communication. Number four, running for a long time, continue, stability, sustained accuracy, and construct and maintain at low cost. This is very important from the point of understanding, particularly with the upcoming technology of AMI ensuring the operational management. This is a matrix which has been prepared actually comparing Zigbee, Bluetooth, and PLC comparison. For example, cost, power, data rate, complexity, density, interoperability, ease of use, latency, interference, security, Zigbee, Bluetooth, and PLC. You select what you want. For example, if you are looking for a very cost-effective solution, go for Zigbee. If you are looking for a very long range, sustained accuracy, sustained system, go for PLC. And then this is how you have to select. That is the reason for training. You understand many things here and implement what you want, what you need to do. This is IEC BIS communication protocol. IS is actually 15959. Okay, And the international specification what we are referring is very important, that is IEC 62053 and 62056. These specifications are being driven through. This is the software driven, hardware driven, and this is the uh, TCP, UDP, etc. That is, transmission protocol control, user diagram control, and then here you have the cellular, maybe GSM, maybe 3G, maybe 2G, maybe NB-IoT. All these I have discussed. Every data has been given. All the things are being given to you. No problem. This is RF, like the vendor specific, like maybe LNG, Trilliant, Itron, PLC. This is G3. This is IEEE 1901.2 vendor specific. This is how the communication is being driven through. Integrated arrangement of advanced metering infrastructure. So as you can see here, this is the AMI structure. This is the consumer metering. This is the smart meter. This is the wide area. This is the MDAS, MDMS, billing, OMS, and then other system. This is how the architecture of a typical AMI is being driven through. These are all the components: smart meter, communication, aggregation, telecommunication, information. This is how the customer, local area, distribution area, telecommunication, and control center. This is how the PLC networking or any other mode of communication or any other thing which you think of incorporating will come here as a system integrated solution. This is AMI integration. This is number of meters. This is network. Okay. NE is network. Okay. And then here is the head end system. Here, customer interface and utility management service. The smartness come from entire system component, and not just one or two component. You can see here how you can next, explain this particular thing. For example, data is read, data is transported, data is acquired, consumer engagement, and data analytics has happened. This is how the technology has driven through. Architecture of HES, how it is done: meter, network, the NB-IoT. This is narrowband internet. Okay, management controller. Here you have the MPLS. This I have already explained actually. IoT platform, head end system, validation and control on the integrated management system. This is architecture of the AMI solution: application layer, okay, data layer, okay, perception layer. So where the DCU is coming into picture. So this is how architecture of the solution. Please bear in mind these are all very important slides and will play a major role in determining, understanding what you intend to do and what you're supposed to do in the philosophy of selection. Okay. I think I will discuss one or two very important case studies on the AMI, which will make you understand clearly on the strategies adopted. Whatever the presentation I have made is definitely culminating, on the case studies. Because more the case study, the better knowledge you'll have. Already I have discussed some 3-4 case studies, Houston, USA, etc. Okay, this is the Malaysian smart project, smart grid project. As you can see here, very important things have been discussed here. The pilot project is funded by Malaysian government. Implementation of 1,000 smart meters in the states of Malacca and Putrajaya. The project is part of TNB. TNB is the agency, that is the distribution agency. Tenga National Berhad is the company. Smart Grid Initiative. This is the AMI tools, DR, okay, enhanced customer service, electricity supply reliability, okay, revenue assurance, efficient business, demand response, your operation. This is how the AMI is driven through. They have selected, based on their experience, okay, and also on the number of applications, okay. And this is the implementation stage. They started, the activity in 2014, and they have given a deadline of 2015, and they have completed it actually. And this is the phase 1, phase 2, phase 3, phase 4. Phase 1, automated billing. Phase 2, load profiling and web portaling. Phase 3, outage notification, load management. Phase 4, new billing, tamper detection, supply, automation, smart billing. Okay, this is how they have connected meter and network performance evaluation, okay, IT integration and AMI services. So here you have the larger AMI rollout. So here meter tender, okay, that is tendering, planning, larger AMI rollout, and then before piloting they have concluded everything. And then here, it has come to the project phase. This is the pilot phase. Pilot phase is the phase where, you determine what you need to do. Okay. And here AMI network and meter deployment backend. Okay. This is how the Malaysian government has done a wonderful job in making sure that AMI is installed. So this is how, the system has been incorporated in a big way. So for example, this is the Zigbee based metering system, GPRS, okay, RF Mesh PLC. This is TNB WAN cloud actually, Tenga National Berhad head end. This is meter data management system, web portal. This is the SAP P1, okay, okay. This is the old existing system is in pink color, yellow is new system, and green is the data concentrated gateway. So this is how the data concentrated gateway 1, 2, 3, as you can see. And then here this is the metering, and here the IT infrastructure, here the AMI services. Most important here is, the TOU pricing, outage notification, DR and DSM, demand response, and the distribution side management, particularly with regards to how the automation has been done in this very important slide, which gives you a comprehensive picture of the Malaysian system, where the tendency to understand the susceptibility, acceptability of this. Here you can see the CMC, the chassis management controller, computational system management. Okay. So this is how the TNB board of directors have endorsed the proposed nationwide implementation of advanced metering infrastructure in 8 million smart meters over 5 years. Okay, beginning in 2015, they have completed everything is there. They have raised a flag here. You see, 300,000 meters, 2 million meters, 8.3 million meters. Compared to the population of Malaysia, definitely these meters are very good. And you have to learn a lesson from this. That is very important. Hopefully, people should understand how you can implement in your area and what needs to be done. Okay. This is AMI case study at Chamundeshwari Electricity Company, Mysuru. Okay. And then what they have done, what they have selected is important here. Okay, these are all the key components: advanced metering infrastructure, residential, industrial, and commercial. Okay, and you have here the mesh network. As you can see, the mesh network, you can see here, this I have discussed all these things in detail so that you understand everything. GPRS, this is MDAS, this is head end system, and MDMS. This is the system Mysore has adopted. Application: energy accounting, demand side management, okay, outage monitoring. So remote meter reading, remote connection disconnection capability, outage detection, tamper detection, time of use tariff, prepaid credit metering, mode with the over the air, that is, that is very very important, we call OTA, that is, change of provision. So this is how, the meters have come into picture. They have selected advanced metering distribution automation system, loss reduction, KPI improvement, key indexes. Okay, okay, performance index. Right here, they have the timeline. Of course, they started in 2014, October 2018. Main thing here, project planning, business blueprint, realization, final preparation. They have gone live actually. And then here, this is the project track, and this is the future milestone they have drawn actually. Okay. So the focus is AMI, smart meter and communication. They have partner is Scion Technology, UK, and they have done a great work with regards to this incorporation. Case study on AMI, CESC Kolkata. So as you can see here, Kolkata, they have organized a beautiful work, on AMI system, on the integrated mechanism with which, the system is driven through. Okay, choice of communication. They have discussed cellular, PLC, RF mesh, and others. Selection of communication technology is the main thing actually. Interoperability, and also vendor selection. How to select a vendor, and selection of meter vendor. Meter vendors are plenty in India today, and you have to definitely accept the meters which are reliable, accurate, sustainable, and also which can fit into the system with which you are talking of today. Multiple make of meters communicating over the same communication network. This is interoperability, very very important. multiple make of meters communicating over the same communication network. Okay, very important. Pilots and POCs. POC is proof of concept. POC on Wi-Fi, one POC, two POC on RF mesh, one POC on RF mesh, three POC on PLC. See how much work they have done. It is not that simply they have incorporated Indian system. You just learn a lot of things from this particular case study, and you will select what you need to do. One pilot on GPRS. So this is how they have gone methodically to arrange how best the system could be integrated. Pilots and POCs, technology, PLC technology, cellular technology, Wi-Fi, RF mesh. Okay. In PLC, what we observe works through our own network, highly dependent on quality of LT network, noise interference. Okay. And then here, cluster meters, multi-storied apartments. Okay. Cellular. Cellular is scatter deployment, manageability difficult, no SLA based service, service level agreement. Okay, scatter deployment, network coverage. Okay, Wi-Fi security is a very big concern because Wi-Fi definitely the security which I will discuss tomorrow, cyber security, how it is. We will talk more about it. Okay, RF mesh, scalability, self healing, auto reconfiguration, lesser number of network devices. So RF mesh is 865 to 867 megahertz was selected for AMI based on lot of studies. What they have done is they have drawn a clear diagram and matrix, and selection criteria has been done based on experimentation. Aggressive and strategic approach. One is consumer awareness through PR agencies. PR agencies is actually the purchase resold, whatever it is. Sharing benefits of AMI, involvement of people, representatives, installation of non-smart check meters at selected points. Okay. RF mesh pilots, like different makes of meters, multi-application, backhaul, backend. They have used different applications. Okay. This is the system with which the communication has been done. This is HES, OFC, okay, fiber, communication device, RF mesh, FTTH, fiber, and here NIC, that is network interface card for the existing meter, RF mesh, meter with NIC, communication device. This is how the approach has been done based on the system engineering. And this is how the diagrammatic approach has been totally synchronized with the model with which they have conceived actually. So meter installed so far, single phase around 7,500, three phase around 850. Because Kolkata Electric Supply is not a big company like Hubli Electric Company. It's a small company because it is only limited to Kolkata city. Street lights and daily red success is greater than 99.5. Okay. And this is the smart grid AMI implementation challenge in Puducherry. This is another case study which I want to discuss with you. Okay. Here, how they have selected, what is the criteria of selection, and how the entire thing has gone. We will see one by one. So, overview and objective of the pilot case study at Puducherry. The main objective of the project include, demonstration of the usefulness of smart meter. Number one, demonstration of time of use, peak power pricing, providing the ability for utility to curtail loads, providing the ability for a consumer to manage energy, improving grid reliability, providing proactive maintenance, managing distribution local through the day, improving billing efficiency. So these are all certain major goals they have put. Objective is ATC loss reduction, failure in customer equipment, reducing how means they will not operate in peak load, and the efficiency of the transformer, efficiency of the generator will improve it. Improving load balancing, increasing revenue through premium services. Okay, these are all the main objectives they have put actually. Puducherry small grid project is one of the 13 grid projects of Government of India which covered under IPDS, erstwhile RAPDRP. Okay, consumers cover 33,499, including 106 1,640 LTCT operated meters, AMI and PLM. That is, peak load management. How to manage peak load. This is very, very important actually. Project cost here, MOP, Ministry of Power, okay, utility. This is the architecture, what they have done. Here, the main IT systems, portal, customer. This is the LTCT consumer. Here, we have the smart meter, as you can see here, communication. And this is the DCU, data control, data concentrate unit. This is the smart meter at home, actually. Okay. So DCU, and then here, the data acquisition system is being driven through. Functionality of smart meter, I think this has been discussed already in the first presentation. I don't think any separate explanation is required. And this is the meter they have selected. This is the photograph of the system they have done. DCU installed in the field. Okay, they have installed the DCU to capture the data and to analyze. They have gone in line with communication technology IS 15959 and 16444 IS specification. Communication system they have used is RF mesh network. You can see here, mesh network has been used. Okay, frequency is 865 to 867 megahertz. Okay, so this is date wise 2021. As you can see here, the date wise, this is the actual DCU type, DCU name, online counts, online rate, and this is the offline. Red is offline, green is online, and some things are unknown. Actually, unknowns are very less actually, as you can see. Okay, smart meter online rates here, as you can see here, almost about 90%, 93% online rate has been observed and they are in operation. That is very important. Total number of system, DCU, online, offline. Okay. This is MDAS. MDAS is nothing but your HES, head end system. It's a software hardware system. So HES MDAS ensures the automated acquisition of meter data, and in the process eliminates human intervention with the data acquired. So the solution enables the user to monitor meters. And in order to make scalability a reality, HES is designed on an open platform based on the distribution architecture. This is the meter data acquisition system. How meter data MDAS particularly acquires the data. Is the consumer load survey. How they have enhanced the whole application. This is MDMS, how the data is managed, the validation, particularly the VEE. Okay, validation, estimation, okay, editing, how it is done, on the MDMS configuration. Peak load management allows utilities to reduce, the demand of electricity during peak usage time, which can in turn reduce cost by eliminating the need for peaking power plants. Very, very important. Very important. You can see here how they have, from this shape, they have gone to this shape, providing a beautiful way for showing how you can reduce your peak load management. And finally, they have gone for the demand response. That is very change in the electrical usage by end use consumers. Okay. I think peak load management has been further discussed here. How the demand side management has done a beautiful job in understanding the criticality of the utility understanding. Okay. This is how they have directed the whole usage of pattern. Okay. Consumer portal, they have understood various things. A web portal has been provided to all consumers covered in this project. You can see either through your laptop or even tablet, mobile, you can upload, you can download, where the individual can log into the web portal of the monitor live historical consumption of data. This also will help the consumer for proper planning and utilization of bills. Okay. So mainly benefit to the utility, reduction in ATC loss. We are looking for this. Online energy accounting, improved load management, improved power quality. Okay. Utility, reduced outage, crew and asset management, renewable integration and net metering. This is how the whole thing has gone. Major benefits. Consumers can log into the portal and can view their consumption pattern. Consumer engagement and empowerment with greater control over the energy and bill, and improved quality, that is very important, reliability, and also the power power outage management system, rooftop renewable, prompted correcting improvement, billing system, consumer satisfaction are most important factors actually. Challenges: choice of communication, select what you want, PLC, DCU, whatever it is. Like, okay. Scalability, integration, cyber security, which we will cover tomorrow. Additional particularly overhead toward ensuring cyber security. Consumer apprehension on high bill, it has been addressed in a very beautiful fashion. So this is how the component structure is being talked about. This is the component of tariff: generation cost, transmission cost, discom cost, UI, interference, particularly frequency interference charges, reactive power management, subsidy, TOU, CPP, time of the use and critical pricing, peak pricing, power supply, time of the day, level of voltage, sanctioned load, frequency of application, penalties on exceeding sanctioned load, injection of harmonics limits. These are all the main things, which will have the tariff structure engaged. So, what is meter data management and how it works? This is very important. Meter data management collects, stores meter data from a head end system and process that meter data into information center that can be used by other utility application, including billing, customer information system, and outage management system. This is a smart home, advanced metering infrastructure, utility office, communication device. This is the smart meter. Okay. So designing an AMI solution, this is the context diagram. You can see here the upper bus, SCADA, OMS, ERP, postpaid system, unified prepayment vending system, mobile app, web portal, GIS. Okay. And here you have SAP business system. This is nothing but your system integrated solution. Reporting. So this is the GUI, graphic user interface. Okay. NMS is nothing but your network management system. How the network is managed. Okay. And here this is the head end system with the network management system, radio frequency, DCU, smart meter 1, smart meter 2, manual meter reading, AMR, supporting devices like the LDAP, the lightweight directory access portal. Okay. And here you have the email portal, SMS portal, and backup. Okay. This is how you have to design an AMI solution on the context diagram. AMI components, meter reading data. Yeah, I think this has been discussed already. The smart meter, the communication, the meter reading, the data management, the SAP. Okay. Processing system is the most important aspect actually. This is how the components are being driven through and addressed through. Integration of AMI for outage management. This is the AMI. Okay. Meter gasps. Okay. This gasping is, as you know, first breath and last gasp. OMI, preprocessor logic filter, useful gasp, advanced distribution management, ADMS, is outage management. Here it pings from the operation, and this is how it pings, and then here it goes to the grid topology information. So the solution leverages the known connectivity of the distribution system. So the grid topology information is fed back to the ADMS. That is, advanced metering data management system. Okay. This is very important. And then integration of OTIT, that is, outage management system. How we can, OT is the operation technology, IT is the information technology. How it is integrated. One is the SCADA solution, which is not very popular today as AMI has taken over the distribution automation system today. Customer information, mobile, interactive voice, meter data management, advanced metering infrastructure, GIS. So this is how the integration has been done on the OT IT solution. Okay. This is another thing. How IT OT is integrated. For example, this is the head-end system with GIS, CIS, etc. As operational technology, information technology, they continue to converge and improve information sharing. Utilities can expedite new business process, new business application, and data management driven through the entire whole application. This is the benefit of the integrated with OM. Like, ability to ping, ability to evaluate, provide the work operator, provide additional information, provide outage, verification, determination, and location, which is with the outages. Smart policy. Before a decision is made on smart grid implementation, a supportive regulatory framework needs to be built and right governmental policy must be in place. Security. The policy is to be designed for the new smart grid ecosystem, must ensure consumer safety, and given the amount of automation, digitization, along with new consumer segmental thing. So the policies must ensure cyber, justice, and security. And also, it have the consumed providers the ensuring robust yet flexible system operation. Conclusion. So at this point, utilities need to analyze their current state of technology, adoption and implement new technology, new process accordingly. The existing system must be made smart grid ready, which requires not only infrastructure upgrade, but changes in current practices and the regulatory framework. So the regulatory environment must be supportive of a competitive market and dynamic processing. To ease and stress on today's infrastructure, renewable, DG, okay, distributed generation, microgrid, and peak load reduction measures need to be addressed, added. Given the enormous scale of implementation in India, takeaways from pilots and implementation need to be analyzed thoroughly to avoid pitfalls and to benefit from the experience. To fully implement the smart grid in India, all stakeholders must work in synergy to develop a unified power ecosystem. This is another important aspect, major aspect. So the real challenge is on how the data is collected, utilized for various data analytics. Okay. The country aims to cut ATC losses to 12% by 2022 and below 10% by 2027. Very, very phenomenal, very important message. And it is in line with international standards. Okay. AMI is the best option, which is digitally augmented electricity infrastructure, which automate, manage, increasing the intricacies on the supply as well as the demand side. Thank you. Any questions? You can contact me. Else, you can
Question is
definitely.
there, sir.
Okay.
Okay. Sir, question is there.
Hello.
Sir, you can check with the chat box.
Hello.
Sir, you can check the message box.
Yeah, yeah. Because I will check it and then can I revert it actually on that?
Any other question from participant?
Yeah, there is a question here from participant. Sir, you spoke about connection, disconnection through smart meter. Is this facility limited to single three-phase home current meter or some can be done? Same can be done. Okay. In LTCT operated HT installations, meter connected at secondary side CT. Why to cut off load at primary side? How will meter operate? Excellent question. Excellent. Very, very happy about this question. I will answer. I think this definitely requires a lot of uh, intelligence to answer. Anyhow, you see, single phase meter, it is very simple because it is a direct connected meter. Any direct connected meter, you can always disconnect the supply and reconnect the supply depending upon the mode of operation what you intend to do. Coming to the CT operated meter, CT cannot be opened. Secondary CT cannot be opened. You have to have a shorting link there actually. Like the additional terminal block you are using in the earlier trivector meter you must have seen. Okay, there an additional bar will be there. that bar will connect to the secondary side of the current transformer, and it will short the current transformer, and you can disconnect the load outside actually during the CTPT network itself. But for the smart operated meter, in the three-phase system, the CTPT loads will not be disturbed, because the load pattern and other things will be determined on the secondary side of the current transformer. Therefore you cannot disturb that. However, this aspect of single phase load throwing or closing is phenomenally taking place in the domestic sector. But in the industrial sector, still, the CTPT operated operation has to happen on the CT bar link, which has not been addressed so far. But the question here is very important, very intricate. The HT installation, the load throwing away will not come into picture, because the each and every day the load is being monitored, and the load is being driven through, and also the load is being analyzed. Therefore, the question of throwing away the load or connecting or disconnecting load in the high tension meter is very rare, and phenomenally it has not happened in the system approach as it stands. Have I answered your question, sir? Is there anything that I should add? I can give you an elaborate reply also tomorrow, but this is the reply for the question. Any other question? Thank you for your patient listening. I'm very happy about your patience. And in case you have any question, please feel free to ask the question, because this is the platform where we can exchange. Okay. But don't think, this is the end of it. You can always contact either through a National Power Training Institute or directly me. You can become friends, on LinkedIn, and then we can open. Okay.
Sir, you can share your email ID, sir. They can directly mail you.
Sure. I will share here. Here itself, share. No problem. Okay. BALAGUBBI at okay gmail.com. Is it all right?
Yes, sir. Yes, sir.
Okay.
Thank you, sir.
Has it come actually? No.
I have to enlarge this.
Okay. Has it come?
Sir, it has come, but I have to enlarge. Anyway, sir, I will be sharing with the bar. It has come, sir. Yes, sir.
Okay. Anything, please feel free to ask any question, because this is the session where all clarifications will be made. It's one of the best questions he has asked. Okay, very nice.
Any other question, please? Any questions, sir? Nothing. Okay, sir. Sir, thank you, sir. Tomorrow we will meet you, sir, once again.
Yeah, tomorrow 2 o'clock we will meet, and sharp 2 o'clock, sharp 3:30 we will close.
I will inform, sir. Today there is a delay in food, sir. That's why, sir.
Because time management is important, as I told you. 2 o'clock we will meet, 3:30 we will close. No problem.
Excuse me, sir. I agree with you, sir.
Okay. Because a lot of things are to be shared. This is the platform where we can share a lot of things actually. Okay.
Yes, sir.
Okay, thank you so much. Very nice of you. Have a nice day.
Thank you, sir.
Thank you very much.